Good days, everyone. Today, I would like to do revision for the coming mid-year exam for the Form 5 and Form 4 student for additional maths. So I will start with the Form 4 syllabus first. So this is actually a good handout for you. You may use a phone, right? Scan the barcode here. So I highlight the barcode here. Can you see the barcode here? You scan this one and then you try to print out on your own. Then you can follow my lesson. Alright, so you print out and then you try to do with me. Okay, so have you scanned? Okay, I let you scan for a while. So this is actually the exercise consists of all the question for function. For example, composite function, inverse function, modulus. Still remember how to do modulus? How to solve the composite function by finding the constant. So I will discuss a few questions on paper 1 and then paper 2 question. Alright? Okay, so have you scanned? Right, okay, then you can print out and then let's start to practice every day. Now for your new KSSM exam, you're in new batch of KSSM. So the SPM 2021 is going to help next year, I guess. So basically the paper 1 question will be short question like this, and then the question is actually according to the buku format SPM. It will start with the BM, okay, and then followed by English. So the question will be something like this. It's more on composite function, right? So the diagram shows the composite function. Okay, FG that maps set A to C. Right, so let's have a look of A and C. Okay, so as you can see, A is the first function, and then we have B and we have C. So we have 3 functions. So actually, in fact, this is composite function. So what the question asks is state. That means when you see state, you just write the answer. The working is not important. The functions that maps A to C. Okay, so let's see the function that maps A directly to C. We just follow the arrow. This is the function that maps the set A to set C, right? So that means A is the object and then C is the image. So this is actually the FGX, right? So we can see that the object is X and then the image is 2X plus 1. So the function is so-called composite function. So we will write like this. The function is FG. The object is, of course, the X here. This is the object. And it will bring the object to the image 2x plus 1. Alright, so that is actually the answer. Just state the answer. So your answer is FGX is equal to 2x plus 1, right? Okay, so we have solved one question. How to find the inverse function for f? Inverse function for f. Okay, so let's see. The inverse function for f is actually, okay, let's see what is the function f first. We have to find the function f, right? So let's find out the function f. Okay, so we have FGX equal to 2x plus 1. So okay, in order to find the function f, we need to find the inverse, right? So the inverse of G. Okay, the inverse of G is, let's figure out the concept. Inverse of G is this one. Alright, this is G. Inverse of G is, okay, we have gx equal to 2x, right? So in order to find the inverse, we always let y equal to 2x, right? So that means we can express x equal to y over 2. So that means the inverse of G is x over 2. So we are going to substitute the inverse of G into here, right? So that we can get the f. So let's see, we have G here, G, and then we'll substitute the G inverse x, right? Then here we'll write 2x over 2 plus 1. Got it? This is 1, huh? Okay, why we need to substitute the inverse of G? So that we can cancel out this one, right? So we say we can find the fx equal to x plus 1. So since we are asking to find the inverse of f, so then we have to work it out. Y equal to x plus 1. So x equal to y minus 1, right? So if we can get x, meaning that that is the inverse of f. Okay, so that is the answer for the inverse of the f. Alright, so the answer for this one is f. You have to write the subject like this. Okay, that means you have, every time when you write the function, you must have the subject. This is called subject. That means if you just write x minus 1, it actually consider wrong answer. Alright, so make sure you write the subject. Okay, there's a basic question for function and inverse function. You must know, it's compulsory to know, right? So let's see question number 2. Now let's go through number 2. Modulus is very popular in exam. Diagram shows the graph function fx equal to modulus 2x minus 3 with a domain x from -1 to 6. Right, so let's see. So this is a modulus graph. Modulus actually is always a V shape, right? V shape. It's a V shape, right? So this is a domain is from -1 to 6. Okay, so state the object of 9. Object of 9. Object means x. 9 means y, or it means fx is the image. So we go to the y. Okay, here y. We want to find the x when y is 9, right? So let's write down. This is actually 6, 9. So that means this is image is a y, and this is a x, which is the object. So the answer is very simple. It's just 6, right? Object of 9 is 6. Image of 4. Where is the image of 4? Now where is the 4? Okay, image of 4. So we actually not sure, so we have to use a function. When they say image, that means this is the x. Fx equal to, what is the modulus function given? 2x minus 3. Okay, that means they gave x, right? Image means that we have to find the f4. 4 is the object, x is the object. So you must know what is the object represented by x. Image represented by y, or fx. So we are having 8 minus 3, which is modulus 5. Modulus 5 will give answer which is actually okay, modulus will give answer positive. Okay, so we are going to substitute 4 here, right? This is the object, and the image is 8 minus 3, which is modulus 5. Modulus 5, the answer will be 5. Okay, for B, answer will just 5. Okay, the domain for the fx from 0 to 5. Oh, that means we have to find the domain means what? Domain means the range of the x. So let's go and study the y from 0 to 5. Here, okay, I'm going to use a color to highlight. Let's see. Then when they say function from 0 to 5, it means that the y value. Okay, so we would look at the vertical 0 here, 5 is here, right? Okay, that means the range from here to here. Okay, this one happened when the graph, let's go to the function. Function is the line. Okay, let's go to the line and highlight. Okay, so what is the corresponding x value? Let's highlight, use a color pencil. Right, this is actually the corresponding x value. So the x is from where to where? Of course, it's from -1. Right, so we can write -1 x, that is called domain. The one that I highlight in highlight in purple color. Let me change to purple color, this one. This is domain. Okay, the red one is actually the vertical reading, is actually the range. This one range. You must be clear what is domain, what is the range. So the domain is here. Domain is from -1 to this point. The range is actually representing by inequality sign. So we got one value already, which is -1 here, and then this value is actually the y here on the x-axis. The y is 0. Then what is the x? We need to find. So let's go to the function here. When the fx equal to 0, fx, it means y. Okay, so when you see fx is y, so we will substitute this one 0. Modulus 2x minus 3 equal to 0. When you open up the modulus, is still 0, because positive and negative 0 is still 0. So x is 3 over 2, right? So we will get the answer. The x is, the x there at this point, x is, I'm going to write the x value for you. X here is 3 over 2. Okay, so it's actually follow the 3 over 2. But if you extend the line further, it looks like it's not just happen at 3 over 2, because you need to make sure the 5 is here, right? Okay, so we need to calculate another value, which is not 3 over 2. So because why? Because this value is also 5. I mean for the y. Okay, let's find another one. 3 over 2, that means it's symmetrical. So 3 over 2. Alright, so let's see. We want to find the x, so we have to substitute fx equal to 5 modulus 2x minus 3 equal to 5. So let's solve it. So we will have the answer 2x minus 3 equal to plus minus 5. That means x can be 5 plus 3, 8 divided by 2, 4. And other one is -5 plus is -1. So it's from -1 to 4. Right? So this is so-called the domain for the function. For the corresponding range from 0 to 5, then the domain should be from -1 to 4. Got it? That means you have to go to the graph and study the changes of the values of the function. Okay, so we have complete the range domain. Now we can actually do the number 3. Let's do number 3 is Okay, we will proceed to the next question, which actually still a paper 1 question. Okay, so let's have a look of this one. Question number 3. So you'll see question like this coming out in your mid-year exam. Okay, so you can try first. Given the function, given the function fx equal to 4 minus 3x, find the value of x when fx maps onto itself. Okay, for this one, actually you must understand the meanings of maps onto itself. Many students cannot understand the terms maps onto itself. So I'm going to explain to you now. So make sure you really understand, okay? So maps onto itself, it means itself here means that is actually object. So we have the function like this. This is arrow diagram. So if this is 1, it will maps to 1. If this is 2, it will maps to 2. Got it? Okay, that means it will remain unchanged. If this is the love shape, it will go to the love shape. Unchanged. Got it? Alright? So that means the object and image will be the same. Alright, so if you have anything here, it will maps to the same thing. Whatever you have, love shape will go to love shape. This is object, this is image, something like that. So if this is x, it will maps to x, right? So we always like to use the x. So that means if you have a function f here, this is a function. So let's write down the function. Okay, we have the function fx equal to 4 minus 3x, right? So maps onto itself means that fx, this is the image and the object the same. Fx equal to x. So you can just substitute like this. That means the fx, which is the image, will be the same with the object, right? So that means you just solve it and you get the answer x is 1. So it means that, okay, let me show you. If let's say you have this function, okay, we're going to draw out the function like this. This is f. Okay, let's say you have 1. It will go to 4 minus 3 times 1, which is actually 1. Right, so the object is 1. Because the question is asking you to find the x. Alright, if other value, it won't maps to 1. That's the meaning. Okay, then let's proceed to the next one. So for the a, x is 1. For the b, the value of h such that f3 minus h equal to 2h. So we have to refer to our function. Our function is fx equal to 4 minus 3x, right? So for the function, we always do that. We just copy exactly, don't change the question, right? Don't change a negative to positive. You cannot simply, you must follow exactly the function. Okay, now what they substitute? The object is, you just follow. Then only you look at the image. Okay, the function will bring the 3 minus h to the image 2h. Then only you solve. This is 3, right? Double check. Okay, we have 2h minus 3h will be negative 5. Okay, confirm, correct, negative h equal to negative 5. So the h is 5, right? Double check. Okay, so we always need to be very careful. Negative 3 times negative h is positive 3h, right? So always double check because we are very careless. Right, let's proceed to the next question, which is number 4, is about the composite function. that you will see all these questions in the coming mini exam. Alright, so you are given the function, fx and gx and gfx express q in terms of p. Alright, so we always start from this is actually the answer given. We don't see this one, we do on our own. Alright, then only we will do comparison. That's how you do. We don't start from, if you start from this one, you will stop. So we start from this one. So I'm going to copy G because it's actually a composite function G fx, right? So I'm going to write like this, P something plus. You see the way to do function is always like that. Okay, then only we see the object. The object is of course the fx, right? Fx, so we substitute the fx inside here, which is 2x minus 7, right? So then only we will simplify. Alright, let's simplify carefully. Is actually 2px, right, minus 7p plus 3, and then only we will do comparison. So let's copy down the function just now, which is this one, 2px plus 5q. Now, so let's see. It seems like we can use a highlighter. Okay, these two already same. That means this thing must be equal to this thing. What the question want? The question want q in terms of p. Now, if q in terms of p, that means q must be alone. So we are going to copy down this one. 5q equal to negative 7p plus 3. So I want my q stand alone. So we want to make the q, which is actually 1q at one side, so we divide by 5. So this is the answer for q in terms of p. Right, q in terms of p. Be careful, sometimes they might want p in terms of q. So p in terms of q and q in terms of p will be totally different. Right, so this is basically the paper 1 question for the function. Now let's proceed to paper 2. For paper 2, the question will be a bit long compared to question in paper 1. So basically, if function, we just substitute. F4 is 4 minus 5 times 4. So it's negative 16, right? This one everyone can do. And then P, okay, for this question, we have to do accordingly. We have to use a function given, use a g, function g here. So we are going to substitute the function with the object, this one. So I'm going to copy the g, g something equal to 3 something minus 5, right? And the something is actually p plus 3, right? So I'm going to write p plus 3 like this. Okay, so then I will simplify 3p plus 9 minus 5. Alright, so I will have 3p plus 4. Okay, so in order to do well in additional maths, you need to always keep on practice. So I have found this already. 1 over 8 f4. Okay, f4, what's my f? Okay, 4 minus 5 times 4, this is f4. So I will have 4 minus, I think just now the answer, right, which is negative 16, 1 over 8. So I'm going to times with 1 over 8 by negative 16, which is negative 2, right? Okay, after I got a negative 2, then I will put back here. So I will substitute into where just now we have g here, right? So this is negative 2. So we are going to solve this. 3p plus 4 equal to -2. That means 3p equal to -6, right? So p is -2. Okay, so you have to keep on practice until you are expert. When you're expert, you will have less mistake. So the answer for p is -2. Alright, now the question asking for g(f(x). Okay, g(f(x). Let's find the g(f(x). So we have the g. Okay, we have the g. We copy down g. Something 3 something -5. Our question 1, the g(f(x). So we will substitute f(x) here, right? And then f(x), which is 4 minus 5x. Then we simplify, it will be 12 minus 15x minus 5. So the answer is just 7 minus 15x. So this is g(f(x), right? Settle. Okay, let's see this one. This is actually many students have problem. Sketch the graph of modulus g(f(x) for the domain -1 to 2. Okay, how to sketch the graph? Let's see. What is our g(f(x)? Is 7 minus 15x with the modulus. See that? Modulus. Modulus 7 minus 15x. This is the question, right? Okay. So in order to sketch modulus graph, we have to follow the domain. We have to find the value of -1 and the 2, and then we have to find the x-intercept and y-intercept. So basically, I advise you to draw a simple table like this. A simple table. You draw a simple table like this. You need to have a 4 value. One of the value is follow the domain. Okay, and end with the according to the domain, -1 and 2. These two value is a must. Okay, so you plug into the calculator 7 minus minus. Okay, you substitute carefully into the function. So here, if here -1, this will be positive 15, so 22, right? If this is 2, will be 7 minus 30, will be 23 negative, but modulus will give you positive, right? Okay, we have solved that value. On top of that, you need to find the x-intercept and the y-intercept. So the y-intercept, it happened when the x is 0. So that means we substitute 0 here, we will get 7. Okay, when the y 0, we will have x, which is 7 over 15, right? That means we let this thing 0. We 0 off here. Okay, that is function g(f(x) 0. Okay, so we have 4 value ready. Then only we can sketch a graph. Now basically, for you to sketch a graph, you need to use a ruler. Okay, ruler is a must. So I'm going to sketch now. Okay, so in order to get full marks for this sketching, okay, this one you can put modulus g(f(x), right? Okay, so we will start with the 0 origin here, -1, and then of course we'll end with 2, right? So just now we have the -1, which is 22 and 23, so we can just label here 22 and a little bit higher 23. So we have 2, which is 23, 1 is 22, and then the turning point is where? Let's find the turning point is at the 7 over. Okay, the turning point is here, 7 is quite close to 0, right? Okay, so let's draw a V shape first. So the V shape will look like this. It go there and then go up. Okay, so this point is 7, right? It's a V shape. Okay, so you have to use a ruler, draw a nice V shape. Okay, use a ruler. It must be a straight line. It cannot be a curve. This is 7. You have to label your y-intercept 7. Okay, so basically you must have the 4 important point. One of the point is actually okay, let me highlight to you the 4 important point. Negative. Okay, let me draw a nice modulus graph. This is not nice. Okay, so we draw like this. So like this. So it's a V shape, right? Okay, so one is a bit higher. This is actually 22. This is actually 23. So these are the important point. And one more here. This one should be negative 1. This one should be 2. And this is a turning point. And this is origin. This is x. This is modulus GFX. Alright, so all the point must be clear. Okay, so this is so-called modulus graph. And then I'm sure they will ask you to find the range of the function, right? So how to find the range of the function? The range is always a y value, okay, for the corresponding domain. So we will actually highlight like this. Okay, how to find the range is you just study the lowest point is here and the highest point is 23. So this is actually the y value, or we can say as this is the range. Instead of say y value or function value, is starting from the 0 and then the highest value of the y is 23. Alright, so this is the range of the function. The range means the minimum to maximum value of the function. Follow the domain of the x from -1 to 2. Alright, so this is modulus graph. Okay, so then we'll proceed to the next question. Question number 2 for paper 2, right? Okay. For paper 2, you will see question a bit longer compared to paper 1. Okay, given the function fx and 4 minus x and gx equal to ax squared plus bx, such as a and b are the constant, the composite function gf -1 was given. Alright, gf -1 was given. So find the value of a and b. So we will find from here, but before that we need to find the inverse, right? Because there is an inverse there. So let's find the inverse. In order to find the inverse, we always let fx equal to y. So it seems like the x is 4 minus, bring over, right? 4 minus y, right? Okay, so that means the inverse is actually same. It's also 4 minus x. Got it? Okay, so now we have the inverse function already. We're going to substitute into the g. Okay, we're going to substitute into the g. So the g was given, okay, ax squared plus bx, right? So g, let me do somewhere here. Gx is, okay, I'm going to do here. Let me copy down. Gx is given, okay, what is the gx given? Ax squared plus bx. Right, so let's substitute. We are going to substitute the g a square plus b. Okay, the one that I leave it blank, you will substitute with the f inverse, right? Just now I have find the f inverse, which is 4 minus x. So 4 minus x and then 4 minus x. Okay, so we need to simplify before we can do comparison, right? So we have a 16 minus 8x plus x squared plus 4b minus, this is x, bx. Okay, 4b minus, let's see. Alright, so after expand, I will try to actually simplify. So I have 16a. I'm going to rearrange. I arrange in order so that I can see the a 16a minus 8a x, then plus ax squared plus 4b minus bx. Alright, so I'm going to arrange in order, which is ax squared minus 8ax minus bx, and then plus 16a plus 4b. Okay, so this is actually ax squared plus minus 8ax minus bx. Okay, plus 16a. Okay, after I check already, I'm going to compare. The one given in the question is, okay, let's see, the one given in the question is what? It is given here. Can you see that? I'm going to write down for you here. X squared minus 6x plus 8. So I'm going to write down x squared minus 6x, right, plus 8. Okay, now let's do comparison. So how to do comparison is you just highlight like this. 1, so a is 1. Okay, we just see the number in front. Minus 8a minus b come with the x is equal to this thing, or the one with the x, right? Actually the x you can say you want to write, but you can cancel out. So normally we will just write the constant. We just write like this, negative 8a minus b equal to negative 6. Okay, because we have the a equal to 1 already, right? Here a equal to 1 equal to negative 6. So looks like our b is negative b is positive 2, right? So that means b will be negative 2. Okay, so you do it carefully, you will get the answer for a and b, right? A is 1, b is negative 2. This is the answer that we got it. Alright, so by finding the composite function, then we just do comparison, right? Okay, so you do it slowly, I'm sure you can do. Okay, so I'll leave it for you to double check. Okay, so basically this is about the function okay, for paper 1 and 2. So we have one more, right, which is actually we need to sketch this function g of x. This is very challenging. Now the question is asking us to sketch modulus g of x. That means this one. Okay, so we have g of x here, but the question wants the modulus. So how to sketch a modulus with a quadratic function? Okay, basically in order to sketch, okay, I have to find a space. Okay, in order to sketch the modulus graph, we have to be very careful. We have to list out all the steps. So I write again. So this is the graph that we are going to sketch. X squared minus 6x plus 8. Okay, first of all, for you to sketch a graph, you basically must have 4 important points: X intercept and Y intercept. First thing is you find X intercept, then Y intercept, right. Okay, so how to find the x-intercept? Let y0. So it looks like if my y0, I will have to factorize, huh? So okay, I'm going to let my y0, which is x squared minus 6x plus 8 modulus equal to 0. So if I take out the modulus, I will actually don't have two value because it's 0, right? So I just use a calculator, or you can factorize. So your x actually got 2, one is 2, one is 4. You have 2 x-intercept, right? Then for you to find the y-intercept, how to find the y-intercept is you must let x 0. Okay, y-intercept is easy. So when x 0, it means that the y, we can use the y as represent modulus. Okay, is actually 0 squared minus 6 times 0. Normally we will just 0 off, right? It's modulus 8, which is 8, right? Okay, so we have two value ready, and we have to follow the domain, right? Remember I say we must have must have the domain, it starting and ending 0 and 7. So let's go to the, okay, so actually you can draw a table, a basic table. So the table must consist of x and the modulus gfx, which is actually you call as you can call as dy, okay, which is actually the function. This is a function. Okay, so we have to follow the domain is from 0, and we have the turning point just now 2, and then 4, right? And then for the domain 7. Okay, so when the x 0, okay, we have one more point. When y 0, okay, let me draw again. So we have 1 2 3 4 point. Okay, so let's draw again. So you should have x and y. When x 0, y is 8, right? When y 0, we have 2 and 4. We have two value, and then one more is the domain. When 7, okay, when 7 we substitute 7 square minus 6 times 7 plus 8 modulus is 49 minus 42, 49 minus 42, so 7 plus 8, 15, right? So we have 15, substitute into the function, then only we will sketch. Okay, how to sketch this graph? This is a very challenging graph. Okay, now I'm going to show you how to sketch the graph involving quadratic function modulus. So basically you can see that all the x are on the right hand side, right? So okay, so we always use a ruler. This is actually the function is gf, this is a y, which is gf negative 1 x modulus. Okay, so when 0 we have 8, right? Okay, so let's say we actually, when we draw the quadratic function, we have a shape something like U shape, right? But this part you have to make it modulus, right? 2 and 4. So the 8 is here, so we will go to the, actually basically we draw the quadratic function, then when negative part we will inverse. Okay, so 4 here, okay, something like this, then only we'll go up again. So this point is actually 15. Alright, so this one is actually 8. Then we have to find the turning point. How to find the turning point is you use the okay, the function is here. So for quadratic function, how to find the turning point? If you have a x squared minus 6x plus 8 is the quadratic function. So basically you want to find the turning point, we always use completing the square x, or you can use the formula if you can remember. Negative 6 over 2 times 1. Negative 6 will become positive, right? So be careful. The formula is come with negative. The b is negative over 2 times 1. So the answer is 3, right? So when x is 3, that means you substitute is 3 squared minus 6, 3 plus 8. So that's how you find the turning point is actually negative 1. So when it inverse up is actually 1. So this point is 1, this is 3, this is 3, 1. Okay, so basically your graph should look like this. You should have a turning point. Okay, so how they give you mark is that you must label this point. This point is a mass 08. This point is a mass 31, 20, 40, and then 7, year 7, 15. So all these points must be there when come to sketching of the graph. 5 important points. Alright, for quadratic function. Alright, so basically when you sketch a graph, after you sketch, you must make sure the graph is labeled with all the points. Okay, so it's actually a quadratic function, but the only problem is you have to make sure the negative part is actually inverse up. This is an N shape. Then only you continue with the line. Okay, so this is actually the quadratic function. So let me see, this part is not so right. So it should be like this, because when you sketch the quadratic function, it's actually U shape, right? Okay, so I'm going to erase like this. So it should be, let me trace again. It should be going down like this, then N shape here, and continue with a U shape. Alright, so this is the modulus. The function is modulus. Let me write down the function. Modulus 1. Modulus x squared minus 6x plus 8. Okay, plus 8 modulus. Okay, this is the y. Alright, so make sure you are well prepared for the coming mid-year exam for the sketching of the modulus graph. Okay, that's all my sharing for the first revision on function. I will share with you in my next video teaching for the quadratic function and quadratic equation. Okay, bye bye and have a nice day.